The title is When Data Can't Move But Insight Must. What official statistics teach us about deploying pets in the real world, and we will, just please. We will explain what pets are in a minute. First, I would just like to quickly introduce myself. So I'm strategic advisor for data management at Statistics Netherlands, which is Dutch National Statistical Institute. And but the reason why I'm here today is my role as chair of the UN task team on privacy enhancing technologies, which is this PET abbreviation, that is part of UN Committee of Experts in Big Data and Data Science. I have honor here to have experts on this topic, and I will introduce them very shortly. But first, I would just like to say a little bit about the session and what are PETs. PETs, privacy enhancing technologies, or sometimes called privacy preserving technologies, are technologies designed to protect the data while it is in use. So this is the simplest definition of PETs, but there are many other definitions that I will not mention here. And the example of that could be like if we want to have statistical analysis, there are techniques that allow that you can do analysis on fully encrypted data, and that technique or technology is called homomorphic encryption, and that's one example of PET, and you will hear about more a bit later. Besides kind of data protection aspect, you can also think about PETs in a role of to help kind of demonstrate or assure compliance with the principles in the GDPR, for example, privacy by design and data minimization, as well as principle of statistical confidentiality, which national statistical offices use in the work to protect the data, not just personal data, but also data from companies, for example, who provide data for compiling official statistics. With this out of the way, I would first like to ask you a couple of questions. First one, how many of you know at least two examples of pets? Please, cats and dogs are not valid answers. So maybe which ones?
Differential privacy.
Right, yeah, nice. Great, yeah. More additional examples, yes? Fantastic, yeah. Oh, okay. Yeah, no, that's great, that's great. So we see we have a lot of knowledge already here. Idea today is, even though that we talk about pets in the context of statistical organizations, a lot of kind of learning from implementing pets are very applicable for other areas as well. So we hope that you will get value from that discussion. Then we will just start with the initial round of 5-minute speaker interventions in the form of short presentations. But before we start, I would just like to give speakers a bit of indication about the audience. So obviously, a lot of you already know pets, but maybe can you please raise your hands if you have a policy background? Okay, yeah, it's like a 5, yeah. Then how many of you have legal background? Yeah, I kind of expected that, and none of us has a real legal background, so that might be a bit of a challenge, but at least we can explain what pets do, and then you can put it in the legal perspective. Who are researchers or data scientists or statisticians, perhaps? Okay, just one, yeah. Fair enough. And finally, who are technical, IT, cybersecurity? Yeah, okay, that's great, yeah. Okay, so that's just a bit of information for you about your audience, and then let's start. So first I will introduce my colleague from Statistics Netherlands, Rosanne Turner. She's there, and she works as a methodology researcher, specifically on privacy-preserving technology, synthetic data, and statistical disclosure control, which is also something that we'll explain a bit later. She has practical experience not just with privacy and disclosure protection for statistical data, but also health data academic research from her previous job. So she will explain what are potential areas of application of pets in statistical organizations. Then we have, besides her, on her right, Robert Pisarcek, and he's CEO and co-founder of Oblivious, which is a Dublin-based company pioneering privacy-enhancing technologies. So he knows exactly how privacy technologies work, and he's excellent at explaining this, not just to his customers, but to anyone basically who is interested. So we will use these skills here. And then we have here on the other side, Yuri Sashko, who is an engineer leading Google anonymization team in Munich, Germany. His team builds anonymization differential privacy infrastructure and helps other teams in Google to correctly anonymize data. And he will provide more kind of practical insights, how this looks like in practice, as well as some information about recent developments and trends with pets. And finally, here we have Dave Buckley, who is a technology policy consultant specializing in privacy technologies and data governance, and he works at the Open Mind Foundation, which is a non-profit organization building open source infrastructure for privacy-preserving AI. And he also co-chairs the UN Pet Lab community, which he will present quite soon. So you will get this information. Thank you all for joining this panel today. And with that, I will just pass to Rob for his 5 minutes.
Matthias. Thank you for the introduction. So I think the title of today's session is "When Data Can't Move, but Insights Must." And I think, in a sense, we all together will try to explore whether this is just a nice slogan or is it actually doable. Hopefully, the former. But I would like to kind of kick off by maybe kind of motivating pets, like why do we even care about them? And just to give a little bit of a background, what they are, how can we think about them? So kind of traditionally, when it comes to, in most organizations, if you want to use data, you want to compute something, you just give access to it, right? Maybe you mask some of the columns, maybe you tokenize some data, maybe you offer partial views, but essentially you just give direct access to raw data. And one thing that we've learned is that this doesn't really scale. There's a lot of examples, so let me give you one that maybe some of you might be familiar with. It's back from the 1990s, when Massachusetts Group Insurance Commission essentially published supposedly anonymized medical data sets that, they said, it's de-identified, no names, no direct identifiers. They just kept, kind of high-level information like zip codes, birthday, gender, along with medical procedure details. The governor of the state personally assured the public that they have nothing to worry about. So one PhD student, Latanya Sweeney, decided to test that. And what she did was she paid $20 for a voter registration list in the US that also included, zip codes, birthday, gender, but also the names of people, their party affiliation. So what she did, she just linked the two data sets, and she managed to de-identify a lot of people, including the governor's medical files, which she just printed and posted to him. So that was one learning lesson, back in the 1990s. So you might think, well, that was ages ago. Surely by now we've learned how to anonymize the data. We can do it much more effectively and prevent things like linkage attacks. So just a few months ago, Anthropic published like 1,200, I think, interview transcripts with users of their products around the product usage, including researchers. They, of course, again, removed the names, removed any identifiers, and so on. So what happened was one Northeastern University researcher took that data set, run this through kind of the off-the-shelf LLM, and de-identified or kind of re-identified individuals in those transcripts. And she didn't do it by some sophisticated hacking. She did it, just by basically connecting the dots, right? So an LLM would take, I don't know, a sentence like, I worked on this type of a research project in this niche field around that time. It would search the internet, find a paper, find the author, and suddenly you have a name attached to that interview transcript. So what's changed? So what's changed is that, LLMs don't just look for direct identifiers, right? They can understand the context. They can understand what you might call kind of like a semantic fingerprint. The way you describe projects, even like the way you write things, your writing style, and so on, and match that against the entire internet at scale. And you can also do it, very often with a single prompt, so not some sophisticated re-identification attacks. So hopefully, you've learned that, removing identifiers and so on is not necessarily an anonymization technique, but also like that anonymizing is actually pretty tricky. So that's exactly where kind of pets come into the picture. Now, I assume that, in a lot of organizations, people use privacy tech in general, things that can help you with managing data subject requests or managing your DPIAs or consent management and so on. And all of those things they're useful, of course, but they operate at kind of what I would call a governance layer. Pets are different. So pets are technical measures that operate at the data layer. So they impact how, they directly impact what we can see, access, or even infer from data. So they're complementary to the kind of the governance tool, but they work in a very different way. So how should we think about them? So let me give you maybe like a hopefully useful framework, how we could kind of think about different pets, because there's a lot of them, and even like at the start we already speaking about quite a few. So in any data processing activities, what you have is you have your data, you have your inputs, you have a computation, you run some computation on that data, and then you have outputs. And different pets kind of endeavor to protect different parts of that workflow. So on the one side, you have input privacy techniques that essentially protect the data during computation. So what that is it's basically, if you're familiar with things like, protecting or encrypting data at rest or in transit, there's like a third pillar that protects the data in use. And that means that, you can essentially make sure that the data is being processed only for a specific pre-approved purpose, not outside the scope of it, but also that you can enable data collaboration, where you might have multiple parties that can collaborate without exposing their data to each other. Now, you've run your computation, and then, of course, you have the outputs, and that's where kind of output privacy techniques come in. So what that is about is how do you make sure that from the outputs of that computation, you cannot reverse engineer the inputs. So that's essentially kind of boils down to effective anonymization. So these are kind of, I would say, two main groups of privacy and seek technologies. As mentioned, there's loads of them. So on the input privacy side, you have things like homomorphic encryption, for example, that is essentially a way of encrypting the data such that you can still compute upon it. You can still manipulate it, add and multiply, and so on. You have things like confidential computing, sometimes also called secure enclaves or trusted execution environments, which essentially help with kind of similar functionality, but with very different trust assumptions. So what you have specific hardware brought out by chip manufacturers, and then adopted by all the kind of cloud providers that essentially enable kind of input privacy guarantees, but with those sort of hardware-based guarantees. On the output privacy side, there's again a whole range of techniques, including, for example, traditional statistical disclosure controls that national statistics offices have been using for literally decades when dealing with things like census data or publishing statistics and so on. But you have some newer techniques like, for example, differential privacy that works by injecting, calibrating noise into your, typically kind of into your outputs. Things like synthetic data, that is essentially kind of fake data that preserves some of the underlying correlations, for example. So the point is that, there's quite a few of different techniques, and they're they differ by use cases, what they can be by their maturity, what they can be applied to. So you always have to be kind of careful and think about starting with the problem before kind of jumping into what is the right path for my solution. But that's something that I would leave for the other speakers, and I think we'll be talking about kind of different use cases throughout the session.
Yeah, thank you, Rob, for this very good explanation, so that we all know what are pets. The previous session was about the agentic AI and risks related to that, and I was quite glad that there was a lot of emphasis, particularly at the end, on the risks related to security, cybersecurity, as well as privacy. So I think, there is awareness, but there are also methods that can be used, hopefully. So with that, I will pass to Rosanne, and she will explain some use case scenarios that are particularly interesting in the relation to the official statistics. We will need second presentation. Let's see if it works.
I think we just need to wait a minute. I think they're doing it.
Yeah. Okay. Yeah, Rosanne, the floor is yours.
Thanks. Great introduction. So I think we have a very clear picture now of all the possibilities and how to protect your data while it is analyzed. So the title of this session included "When data can't move but insights must." So what does that mean for official statistics? In official statistics, we help the government, economies, or the public to really understand and make decisions about the world, so about the economy, the population, society, and the environment. And we also support scientific research in addition to making statistics. So this is a big task, and we do this both on a national level and on an international level, so on a European level or sometimes on a global level. And to this end, we have to share and collaborate with a lot of data and lots of different types of data. And as Rob already showed, even when you just combine two published sources of data, you already increase the risk of disclosing sensitive information. So imagine what happens when you publish each year thousands of data sets. These risks of combining specific types of information get big very fast. So protecting against these risks is a very complex task, which is the area of statistical disclosure control. And this often results in a bit of a gray area when we decide to publish a data set or to collaborate with data. So do the benefits of being able to produce a statistic or to perform research outweigh the privacy risk associated with them? And this is where PETs can potentially unlock more projects or improve existing projects, I think. So one of the first major potential areas, I think, is offering safe access to microdata research environment. So enabling research on our microdata is a large part of work, what we do at Statistics Netherlands. We can't publish or give all our microdata, so the original data, to researchers when they want to answer specific research questions. But what we can do is allow them access to our protected microdata environment, which is isolated and where output is completely controlled. However, often the researcher wants to bring in their own data and also link that to our microdata. And this is where it gets complicated because the data from the researcher also often can't move because they have their own topic-related legislation they have to adhere to. So this is a very interesting use case to apply PETs and see if you can perform this research without actually moving the researcher's data or moving our microdata. Then a second example, which is kind of a bit like the first one, but slightly more complex, is the secondary use of data and the potentials for data spaces. So there are, at least in Europe, a lot of developments around creating these data spaces for secondary use of data. So, for example, in the healthcare field, there's a lot of development recently. And the idea of this is that data currently stays in these data silos. So, for example, at hospitals or at care providers, and they can't be used optimally for gaining knowledge, for performing research, because it is very difficult to move that data, and there's also not a system in place to enable this. And often these hospitals also need National Statistical Institute data to be able to link them correctly or to add certain very important variables for an analysis. So this is also where national statistical officers could take a role, either in more of like a governing role, or at least in a role as a party in an analysis. A third, I think, exciting opportunity are the possibilities to work with new data sources. Because a lot of the data in official statistics comes from registries, but also a lot come from surveys and is data that people send to statistical offices. So, for example, these could be data from people filling in surveys about their budget, about their location, or data from companies, or even data from mobile phones in some cases. It's often difficult and also intensive to collect these data, and people are not always able to move that data or not willing to move that data, and PETS could potentially unlock a whole new source of data here. Oh, and here the colors of the slides are have changed a bit. So it was supposed to be the red devils on the left for Belgium, and the orange orange data silos on the right to represent Holland. But a fourth example is cross-border statistics. So especially when you're going to share data cross-border, this is especially sensitive. On the other hand, we have a lot of projects where we do, especially for Eurostat, and it's also very interesting to see what PETS can add here to unlock being able to produce new statistics or to produce statistics that we already do in a safer way. And the last thing I want to say is this will become more and more relevant as we're going to use machine learning and AI more in official statistics, either to support the statistical process or maybe in analyses as well. So as a statistical institute, you mostly have access to a few compute servers, but of course out there are much more facilities that you can use. And how to use other compute facilities in a safe way is, I think, a very interesting question and could also potentially be solved by PETS. And this is where I'll give the floor to you.
Yeah, thank you, Rosanne, to highlighting some scenarios. So those are from official statistics, but some of them might be applicable in other areas. So, for example, I was at another session that talked about the access to data from platforms such as Google, which is now possible for researchers under the European regulation. And you could imagine that some of those safeguards could be put in place by big companies to protect the data, but still offer a possibility for research. With that, we go to Yuri. Yuri will show some practical examples from his experience. Thank you.
Yeah, thank you. Thank you very much. All right. Yeah, so I wanted to sort of evolve this conversation a little bit. Gen AI is a thing these days, so Gen AI is important, but also, like Rosanna and I, we spoke just before, and I asked like how old is the field of statistics and, statistical disclosure control and techniques. And I think you mentioned 40 years. Right, so it's basically we have 40 years of experience there, for statistics. We have how many years with Gen AI? ML has been around for a while, but it's evolving extremely fast, and in many cases we just don't know, right? Like what privacy means in those situations. But we do know something, and I wanted to walk you through, what we know today, how do we reason about privacy, and what kind of privacy-enhancing technologies exist today. But maybe before that, why Gen AI is special. First of all, just the scale of this. If you imagine the data, how much data is consumed by Gen AI, And second, type of data. It's much richer than statistics. It is text, it is images, it is audio. It can input all those modalities. It can also output all those modalities. So how do we deal with that? The other thing is that ML model, a GenAI model, is like a black box. What does it mean? We have billions of parameters, right? Sometimes trillions of parameters. Okay, excellent. So how do we reason about privacy of that, right? It's very difficult because it's very opaque in a sense. And those are some of the reasons why GenAI is special. So when we look about typical flow of GenAI, those are some of the stages. We collect the data, right? We then train the model, we fine-tune the model. Then we have the actual model, all those billions of parameters. And then we deploy the model either on device or on the server or in some products, right? So, and what is remarkable that is at each of those stages you can apply different types of pets, right? And they can be complementary. For example, if you want to protect your training data, there are many ways to achieve this. There are multiple ways, and you can sort of like stack them together, right? But for example, for training data protection, you can use synthetic data instead of real data, instead of sensitive data. This is one of the ways. Or you can train your model in a way that doesn't memorize individual samples. This is called private training. It goes into differential privacy, right? But basically, there is a way to kind of train the model in a way that learns about generic facts, but doesn't learn individual samples. Or we can apply additionally to that input and output filtering. As usual, there are trade-offs when you choose how to achieve particular privacy outcomes. There are trade-offs. Some of them are more expensive in terms of computational resources, expertise required, engineers required, but some of them provide more utility, and there is always a balance here. Okay, so there are pets for GenAI, right? I just showed you some of them, but there is also GenAI that can be used as a pet. GenAI can be helpful for privacy, and I wanted to show you how exactly. One way, and sorry for the kind of technical slide, but basically here what it shows, we can generate synthetic data using LLMs. Imagine that you have conversations or texts or documents, and there is a way to generate private copies of those documents with strong privacy guarantees, with differential privacy that reflects the properties of the text, the same distributions, but it's safe, right? And Google, for example, used it to build a safety classifier, right? Because, the actual messages are very sensitive, especially, like unsafe messages in a way, especially sensitive. But if you generate synthetic versions of those, you can apply, you can use it to train the model. What is remarkable, GenAI helps here. GenAI is used to generate this sort of data. The other one, okay, I have GenAI generated image, but this is about generating insights about how people actually use LLMs. Maybe raise of hands, how many of you use LLMs daily? Okay, interesting. So some people don't. But basically, I think a lot of people do use, and the question is, how do people use GenAI? What for? Some people use it for studying, some people use it for, like search, some people use it for work, some people use it for coding. How exactly do people use GenAI? This is a very interesting question for all kinds of things, for debugging, for product improvements, for just, like sharing with the community, for sharing with research, for example. This is a very interesting question. And there is a way to do it in a private way, right? So this is exactly the point of this. And all this, the solution that is shown here is actually driven by an LLM. So the way to do this is to look on those individual conversations, summarize them using LLM, cluster them into kind of groups, and then within each group, try to understand what is actually that group about. Is it about coding in particular programming language? Is it about like searching particular information related to pets and something like that? Basically, whenever there is a group of kind of classes of usages of LLMs, this is possible to do it in a private way. All right, and with that, I will give the floor to Dave.
Awesome. Thanks, Yuri. Are you gonna? Okay, I'll intro myself. Yeah, I'm Dave, as Mattia said. So I work for a nonprofit called Open Mind Foundation. We build open source tools for privacy-preserving, decentralized AI. And I also co-chair the UN Pet Lab, which I'll talk about a little bit in the next few minutes. I guess I'm going to give sort of like my mental model for how I conceptually think about privacy-enhancing technologies, which will hopefully, at the very least, be complementary to what others have discussed. But I don't know, at least in my head, this helps me sort of think through, okay, what does this mean in terms of like the governance and the policy implications of these technologies? And I guess I'd like to start from like a very fundamental question, which is like, what is data sharing? Like, what actually does it mean in practice to share data, right? And typically this means I have some data, I want to send it to somebody or some institution or organization, I make a copy of that data and I send that copy to them over the internet, right? But like the sort of challenge with this paradigm of data sharing is that like as soon as you have shared that copy, you've essentially ceded all technical control over that data, right? So that third party can see any sensitive information that's in that data. They can do whatever they like with it. You know, even the intent with which you shared the data initially, in principle, they could sort of not do that, or do anything else they might wish. They can also sort of share it onwards in any way they see fit without you being able to track that at all, right? Now, obviously, we have regulations, we have contracts, we have licensing that, in principle, try to protect against misuse of data. But from a purely technical perspective, we don't have this, and this is one of the fundamental issues I think that we're trying to resolve with privacy technologies. And I guess you might say at that point, like, okay, well, you can just anonymize the data, right, and then you can send it, and it's fine. But I think, as Rob and others have pointed out, traditional anonymization, pseudonymization techniques are limited, and I think now, especially with AI, we can potentially scale so that re-identification is much easier than it once was. So either, if you anonymize data, you're either sort of not actually really anonymizing it, or potentially you're having to put in you're having to de-identify the data sort of so much that data loses its utility and quality, right? So none of this is ideal. So what do we do? The answer, as you might sort of predict, I'm going to pose is privacy-enhancing technologies, right, as a way to sort of change this model. So this idea, as is in the sort of title of our talk, how can you use privacy technologies to enable you to extract insight from sensitive data without copying it, without exposing it, without moving the underlying data? So kind of in this paradigm, it's very different, right? The data holder stays in control. I think this is really important because it gets us beyond thinking just about privacy in terms of protecting like the sensitive information of the data, but also about data governance, right? So not only can data be kept more private and secure in this paradigm, but can it be much more effectively governed because a data owner, they have the only copy of that data, they can impose usage policies at a very like fine-grained level, right? So you can say, okay, who can access this data? What purpose can they use it for? And because you have full control over that data, you can monitor that, and you can have more provable guarantees that misuse hasn't occurred. And I think it's just fundamentally a different way of processing data, right? And it enables forms of collaboration that may previously not have been possible because you can exchange insights rather than having to exchange raw data. Which I guess brings us to the Pet Lab. So the UN Pet Lab is a community that brings together statistics offices, pet startups, pet researchers from academia, nonprofits like OpenMind who, all have an interest in these technologies and applying them in the field of official statistics. And I suppose the Pet Lab itself has more of a practical focus. So we're trying to think, okay, how do we move from just sort of talking about privacy technologies and their potential to actually trying them out in the real world? I think national official statistics is like a very interesting area to work in because, statistics offices provide like a really valuable public and social good to society, right? We measure things about the world, which enables us to sort of, in theory, implement better policies, which, are helpful to society. But at the same time, statistics offices are entrusted with, lots of sensitive data from its citizens. So they're constantly balancing these two properties, right? How do we sort of protect our citizens' data at the same time as providing value back to the public? We've done a number of different pilots through the Pet Lab in the past few years, some of which Rosanna sort of spoke to in her presentation. So enabling like external researchers to be able to research using microdata held at national statistics offices. And doing that in a privacy-preserving way. And then also like international collaborations. We have an ongoing work stream at the moment that's looking at sort of doing federated learnings, this idea that you can train a machine learning model across different jurisdictions without the data ever having to sort of leave one of those jurisdictions, which potentially, in theory, makes it possible to train that kind of model on that kind of data. So we're kind of trying to, really move beyond theory and try to prove that these things can work in practice. So I guess kind of how I'd wrap up is sort of so this pet lab is kind of very much working in this realm of international collaboration. But I think what's interesting in this PETS-enabled kind of paradigm of doing data analysis is that you can have collaboration, but you can also have like genuine sovereignty. If you work in like tech policy circles at the moment, you'll know that like sovereignty is like the buzzword, right? Everybody's talking about AI sovereignty and data sovereignty. I think a lot of people like to use this word, but maybe don't have good ideas for like how do you actually operationalize that in practice. I think PETs are quite interesting because you can clearly, if you have more control over your data, as I've been trying to describe, like that can enable you to have like genuine data sovereignty, right? You can use that data, you can make it available to others you want to make it available to, but you don't have to give up control. So you can have genuine data sovereignty at the same time as also being able to collaborate. And I think that's potentially like quite a powerful thing, for data governance moving forward. So I'll finish on that, I think.
Yeah, thank you, Dave. I'm sure we will get back to those topics like data sovereignty also a bit later in the discussion. But now I would like to ask first Rob, what are the pets that are already creating real value in industry today? So some kind of concrete use cases we promised to say about absolutely. The real world experience.
Yeah, absolutely. Very happy to share a few. Like, I would say that up to this point in general, probably the biggest adopters of PETs would be like big techs, like, your Googles and Metas and so on, and actually public sector, like National Statistics Office. As kind of mentioned, National Statistics Offices have to care about it when kind of sharing data or when trying to get, third-party data. So kind of this data sharing, I think, as Yuri said, Google has a lot of kind of use cases. I think one that I also quite like is the Google Maps busyness thing, right? So if you go to like Google Maps and you check how busy a restaurant is, that's actually all that information is actually differentially private. Or if you go to like Google Trends and so on. So it's like, how do you share data in such a way that prevents re-identification? So that's kind of like a very big one. But we at Oblivious, we mainly sort of work with, I would say, kind of financial institutions, payment processors, and healthcare providers. So those kind of institutions that on one hand, they're not big techs with so many engineers and so on building those tools internally, but at the same time, they sit on incredibly rich data that's very sensitive. And of course, they have important reasons to make sure that the data stays protected. And that's where we kind of see a whole range of kind of use cases. Maybe let me share kind of three main ones or even kind of groups of use cases that we see. So the first one kind of ties to what Rozan was talking about around kind of data silos. So, if you're a bank, you have, for example, really rich transaction data based on kind of payment of customers. And you might want to use that data to, for example, detect fraud or to optimize pricing or to have to personalize product offering and so on. But very often the challenge is that, that's not done. That's not done because it's not important or because the data is not valuable. It's actually the opposite, right? The data is super sensitive. And a lot of those organizations would think, well, let's build like data lakes to bring in all of the different data and then give access to different teams. And then, the DPO, but also your CISO would come in and say, no, we cannot suddenly expose all of that information to thousands of integration engineers, software engineers, data analysts, business analysts, and so on. So this is exactly where things like, for example, differential privacy come in, where you're able to allow different teams to process the data get the kind of aggregate statistics without ever seeing the record level information and only seeing kind of differentially private outputs, right? So you can have this sort of kind of break those data silos between different parts of the organization and enable kind of not the actual data sharing, but kind of, as I think the title of the session is, kind of sharing the insights between different parts of the organization. So that's kind of a very powerful and common use case. I think Yuri also spoke about synthetic data. So where we see a lot of usage of synthetic data is maybe in a sort of typically maybe more mundane use case, but I think like a powerful one, which is for testing new production environments. So whenever engineers build new features or new products or new systems, of course, you typically want to test it with some realistic data. Now, the challenge is like you don't really want to use production data to do that. And that's exactly where kind of synthetic data come in, where they can help you really kind of stress test your product, but also make sure that, you know, your privacy teams and legal teams and so on kind of raise alarms. And then kind of the third use case is more on kind of group of use cases around kind of data collaboration. And that's something that, again, we see in different industries. But, you know, if you look at healthcare, for example, you know, kind of a patient story is pretty fragmented, right? Hospital A has electronic health records, right? Hospital B might have some imaging data. Like labs have some test results. Then you have like wearable devices these days that collect loads of information about patients as well and people. But of course, you know, to have very often kind of the best clinical decision, for example, you would want to combine the data from those different sources. But for a lot of reasons, it's not that easy to just put that together. And that's exactly where, you know, for example, input privacy techniques like secure multi-party computation or confidential computing can come in, where you're able to combine the data in something like secure enclave, make sure that it's only being processed for a specific pre-approved purpose, and you get your output that you were sort of hoping for. So that's of course also in the context of things like European health data spaces, and that's where kind of the pets also play an important role. But those are kind of, I would say, kind of the three major types of use cases that we see.
Yeah, thank you, Rob. And maybe then in terms of the official statistics, Rosanne, are there any successes in applying pets in that area, like besides your scenarios, high-level scenarios, some concrete cases?
Yeah, sure. At least at Statistics Netherlands, 2 use cases really stand out, I think. You can also find them on the case repository of the UN Pet Lab, which was on the QR code. Oh, now it's gone. I'm sure we can find it again.
There you go.
Yeah. Yeah, so those 2 cases, they're quite a different subject, but they have a few things in common I would like to highlight. So the first use case was a Care for Data project, where Statistics Netherlands collaborated with a hospital and with a health insurance company to study a disease that's very difficult to study because the information that you need to study it is actually divided over a couple of domains, like Rob already mentioned, like healthcare is fragmented. So this was irritable bowel syndrome, and we wanted to answer some questions involving also the lifestyle and socioeconomic factors influencing patients. So the second use case was a collaboration with the National Institute for Public Health and the Environment, and there we actually wanted to study some data from supermarkets. So for both use cases, we ended up using multi-party computation and homomorphic encryption as solutions. And what really made these projects what brought these projects to a success with regard to implementation is that we had a very clear agreement on what we were going to study. So the objective was clear, and it was clear that it fit into our task also as a National Statistical Institute. And the roles and what happened with the data was also very clear to us. So in both projects, we had compute nodes at our own facility. So we really felt like we were in control. And in the first project, we made clear agreements on the analyses that could be done through smart contracts. And in the second project, we had the compute node, but we also were the owner of like the central node in the multi-party computation that directs the whole process and where also the first output goes. So we as a statistical institute could be the first to look at the full output, so the data of the parties combined. And as Rob highlighted in his first presentation, when you combine these data, suddenly new disclosure risks can emerge. And that is where, we need to be in control as a statistical institute. That is our task. So, and with this project, we could do it because the infrastructure could be arranged in such a way that we could be in control of this output. That's not always the case for all technical solutions for PPT. So what also helped with this was that we were collaborating with quite mature parties that offered the multi-party computation solution, and that they could really think along and work together with us to orchestrate the process such that it was completely transparent to us. Yeah, so.
Yeah, thank you for these examples. And you mentioned, like a note and what is needed. So maybe the question for Yuri, what are the capabilities that organization or institutions would need to successfully operationalize PETs and collaborate that way?
Yeah, I think maybe one point that Google is maybe the practices that work for Google may not apply, like for example, to smaller companies. So I'll try maybe to think about like how to generalize what Google has internally to other companies. But I think maybe my first principle is that privacy should be done by design. So pets are not like something that you sprinkle on top once you build the product, right? So pets is something that you have to design in advance when you actually plan and design the feature. So at Google, for example, this is implemented by having a privacy program. Whenever engineering team wants to launch something, they usually go to privacy engineers, right? They usually have their own kind of privacy sub-team, right? Internally, we call them privacy working groups, PWGs. And this is how privacy works. And this is exactly the stage where you need to think about pets, right? So not later, because that becomes really hard once you already have your own data flows, you have your pipelines, you have data flowing, and suddenly, okay, I actually need some privacy at those stages. It is very hard to do in those cases, and I think that's maybe my advice number one is like have some sort of privacy program, right, that applies early in the development of the product, right? This is advice number one. Also, it helps to have a pets team, like obviously, if you have a small company, right, it's hard to have a pets team, but it does have to help a pet professional, a pet expert. What worked really well with, like anonymization team and Google, that also we are a cross-functional team, right? It's not just engineering, it is engineering, research, legal and policy teams, right, working together, that really helps. And what is interesting that, like engineers learn to speak legal language a little bit more, and, policy, our policy friends, they understand technical aspects. So that being a virtual group, PADS group, helps a lot, right, to make progress. So I think being, cross-functional and wearing multiple hats, engineering, research, legal and policy helps a lot. That would be maybe a couple of takeaways.
Yeah, very interesting, because also, in my experience with this project, the kind of knowledge and these skill silos are often the issue, that people don't really understand each other when they need to solve some problems that are, cross discipline, like a legal and technology, for example. That's very important advice. I think we are moving now from kind of what are opportunities with pets and benefits of pets to what are challenges. And I would like to ask Dave, some pet technologies are quite complex, there is a cryptography involved and the kind of distributed architectures and protocols and stuff like that. How do we assure transparency? So, for example, I don't know whether you heard the word pet washing when kind of companies try to say, this is going to solve all these problems, but it might not, or it solves certain problems or certain risks, but not some other risks. So the transparency is very important. Then auditability, so that you don't just trust pet provider, but you are able to have some sort of independent proof that actually pets or certain pet will do what it claims to be for. And also important public trust. So like some terminologies, pet is full of certain terms. I don't know, in differential privacy we talk about the privacy budgets and epsilon and stuff like that. So how do we kind of communicate this that users and general public really understands how this works and what is the value?
Easy question. Yeah, I think there's a few things here that we can dig into. I guess maybe an analogy I like to make when thinking about this is if you sort of just look at standard encryption, right? So all of us probably right now, right, literally, like you have a phone in your pocket that's doing things, probably using like TLS that's, sending encrypted messages over the internet. Some people in this room probably are, maybe cryptographers and understand how that works. I certainly don't. And I imagine, your average person does not need to understand how encryption works, but they need to trust the system. I think there's a few different components to this, right? So it's, as I said earlier, so I work for a foundation that builds open source technology. I think like open source has a big role to play in pets as well. I think particularly when you're looking at, say, things like encryption schemas, right? So I think, we now have long-standing appreciation that security through obscurity doesn't really work. There are a lot of benefits to having, say, like encryption protocols be public so that they can be essentially that they can be attacked, quote unquote, to increase the robustness of their security guarantees. I think there's like similar parts that we're going to get in this kind of pets ecosystem as it develops, where it's like that should be open so that it can be scrutinized properly. Particularly when you start to think about pets potentially as like communication technologies, right? So you're trying to do analyses and enabling analyses between different entities. There could be a world where we end up with some kind of like standardized protocol by which we do that. And I think in much the same way that like we enjoy the internet being open because it's built on open protocols, I think there are parts of that technology stack that we'd want to be open. I think that would help build public trust. I think this question is also, probably particularly important when you're looking at like public sector use cases. I just think at the moment, like, if you can't tell, I'm from the UK, and there's a lot of talk at the moment in the NHS, right? So in principle, we have this, going back to the 1960s, very rich health information records that in principle you could do lots of really useful research and analysis with that could lead to societally beneficial outcomes like people living longer, people being healthier. It's very hard to use that data, and you'll see at the moment there's a thing called the federated data platform, which a contract for building this federated data platform, which is aiming to sort of join up certain operational data sets that exist across the NHS. That was awarded to Palantir, which in some circles is very controversial, right? But I think whatever you think about that, I think what is challenging with the use of the NHS, which is considered by most citizens of the UK, right, to be this great national asset that we're really proud of and is like a great public good. I think the idea of having a private company where we can't see the technology that they're actually using to handle our data. Most people can't really understand what a federated data platform is. I think that becomes particularly challenging in a public sector context. So again, I think kind of if we're gonna have like open platforms, particularly in the public sector, that feels super important. And maybe the final thing I'd say, and maybe final two things quickly, is like, again, I guess I started off with this encryption analogy. Again, me being able to pay something using my bank details online and be assured that all that information is protected, I guess that relies on this rich kind of ecosystem of institutions and standards bodies and certificate authorities and all this kind of stuff that has to build up over time. Again, as pets become more mature and perhaps more widely adopted, we'll probably need those kind of institutions as well. And then the final thing I was going to say was just like, if you want to build public trust, you also have to like build stuff that works for people. So again, I guess I was talking about health. If you can use these technologies to build technology that brings about outcomes that are unequivocally good for society, that's probably quite a good way to get people on board, right? Improve their lives.
Yeah, thank you. So it's also a bit of a timing. So of course these things evolve slowly, but I think with all these risks that are just coming up from new technologies, I think there is great opportunity to progress also these areas that you mentioned. Maybe Rosanne, in terms of the statistical organizations, are there some specific challenges? For example, talking to researchers, they sometimes mention how to monitor quality of data while not being able to see it. So
certainly.
maybe you can comment on that.
Yeah, so currently researchers are used to being able to see all the data that we provide for them when they work with it on our microdata environment, for example. This also holds for some other parties besides researchers that work with our data on our environment. So generally there are two approaches you can take with PETs here. So the first, which we also used in these two success projects I mentioned, is that you, on top of your analysis that you want to do, when you want to check for the quality of your analysis and the data that you're combining and linking, you have to add some extra queries to the system to check for your quality. So for example, ask for some summary statistics of the data, ask for the number of links, maybe ask for some other performance measures. So add lots and lots of extra queries, write lots and lots of extra multi-party computation programs or distributed learning programs to calculate all these quality indicators and then see if you can trust them as well. But of course, this also poses an extra risk because when you have a query budget or when you use smart contracts, the number of questions that you can ask to the system is limited to prevent this risk of combining information until you can disclose some sensitive information on individuals. So that's one way to take. The other way, and there I want to highlight another interesting project that's also in the UN Pet Lab repository, was a collaboration between Statistics Canada, Istat from Italy, and Statistics Netherlands, where they actually built in the quality control into the PET. So there they use a technique that's called private set intersection, and they tweak this a bit to already calculate the quality of calculation of a mean of, I think, the number of international trade transactions. Of course, when you do this private set intersection, you want to link transactions between two countries, but there might be false links, false positives, false negatives, and they already built this into the calculation of these means. So that's another way to take. So adapt your algorithm or add extra quality control checks, which might be expensive. So yeah, open question.
Yeah, thank you for this very practical insight. Feel free to look at the Pet Lab repository that is available behind this link, which is also going to be updated with new case studies that the Pet Lab is working on. I would like to kind of go into the final phase of discussion. So maybe go a little bit back to the kind of data governance related matters. So first, in this conference, the digital sovereignty seems to be quite a hot topic as well. And of course, in relation to data, we are particularly kind of interested for data and AI sovereignty part of the story, and probably the open source can play a role here. Yuri, can you explain a little bit how Google, what is the policy of Google with open sourcing these algorithms and libraries that you are using? So maybe organizations can then also use them in their own, cloud of choice or locally.
I'll just keep it short. We try to open source as much as we can, right? So all the paths we talked about today, zero knowledge proofs, differential privacy, federated learning, multi-party computation, they're all there. So github.com/Google, that's, it's all there. But also we collaborate, for example, with OpenMind, github.com/OpenMind, I think that's a pointer. For example, we actually built a pad together with OpenMind called Pipeline DP, which is, differentially private framework, right? I think, it's all there. I think it's important, to know how to apply it. We talked about the expertise, right? We talked about the nuances, right? It's very important. So it's not as easy as just, plugging it in yet, but it's all out there.
Yeah, and I think we all agree that open source plays important role in this, not just in terms of the code and the libraries, but also collaboration, and that's also part of this alliance of statistical offices that are collaborating here. Then last question will be for Rob. You already mentioned some examples from the generative AI. But how do pets change or the way organizations think about AI deployments and governance?
Yeah, absolutely. So Yuri mentioned kind of few already use cases, kind of pets for Gen AI and Gen AI for pets. There's a whole range, of course, of use cases from like federated RAG systems and how pets fit into that. But let me maybe say a few words about one particular use case, which is kind of typically called confidential AI. And kind of the context for this is, if you go to your favorite LLM, whatever pose, you send a prompt, you send some data, maybe attach some files and so on. How do you know what happens to that data, right? Of course, there's T's and C's. But for example, as a sort of engineer, I'd want to have the guarantees that not just on a piece of paper, but actual kind of mathematical or kind of technical guarantees about what happens to that data. Or, who has access to it within that organization? Does it get shared with further parties so that you suddenly get kind of exposed to whole kind of supply chain attacks? So that's kind of like a big topic. And that's where kind of confidential AI comes in, where basically you can use confidential computing to deploy your models either for inference or for training, where the model providers can give cryptographic guarantees that they don't actually see users' queries, they don't actually see users' data, while at the same time they can kind of sleep knowing that their IP or model parameters and so on are not exposed, so they can also protect their IP. And that's kind of like a broader topic in general in SaaS. So it's not only kind of in the context of AI. So literally, I think last year, like the JP Morgan CISO published like an open letter to third-party suppliers saying that, we've been using SaaS and that kind of whole SaaS model has really kind of exposed them to massive supply chain risks. They've built security boundaries over decades and suddenly now they're sending data to third parties and that they're sending to other parties and so on. And that's got to change. And then we need to think about other solutions like confidential computing to deal with that. And when I actually heard JP Morgan CISO talk about that a couple of months ago, literally just after that there was a big kind of attack. I'm not sure if people are familiar with it, on Light LLM. So Light LLM is one of the most popular proxies, kind of AI gateways out there. It's like 100 million downloads a month, like powering thousands and thousands of agentic deployments. And what happened was that attackers managed to put malicious code into the kind of the open source code base of Light LLM that could basically exfiltrate, harvest, and secrets, keys, and send it to a remote server. If you have it in your own infrastructure, you control the infrastructure, you can set your standard firewall rules and make sure that that doesn't get leaked. But if it's a SaaS deployment, if it's a shared cloud deployment, and so on, you don't really have any control over that, and you have no idea what happens. And there's been a lot of organizations that got breached because of that. And that's again where kind of pets can come in and help. If you things like, with privacy techniques, maybe like confidential computing, you can actually, as a provider, as a SaaS provider, you can actually attest to, what is the outbound allow list of connections and where the data can flow. So you can actually cryptographically prove that rather than just rely on, policies or terms and conditions. So it really kind of brings, technical controls into kind of the whole data processing and data governance in the context of AI.
Yeah, that's a great example of another kind of benefit of pets. Now we have 10 minutes, so I would like to open the floor for the questions.
Hi, I'm Shura. I have a question for Google, but it also is a question about the limits of pets for the rest of the panel. So you showed this nice cleaning pipeline generated with generative AI to clean up the contents of dialogues in generative AI and to get statistics about what do people use generative AI for. This makes me wonder why your company, and I'm not saying you are Google, but Google refused to provide access to the European Commission in the context of the Digital Markets Act to search queries because it was impossible to anonymize it in a correct way, according to Google. And I'm wondering, if you have this expert team, right, of pet engineers, is it really that impossible? And that's also a question for the other panel members. Like this, to me, it sounds like a challenge, not something that is technically impossible, but it's more a question of not willing, maybe. So sorry if I put you on the spot there.
No. First of all, I think it is possible. I think it's totally possible. I think it's
the engineer,
I think it is possible. When you look about this pipeline and conversation, imagine your conversation with Gen AI, right? Like imagine your conversation with chatbot. It can be really, really personal, right? Like you can talk about really personal things, like medical conditions, struggles, things like that. And that's why here it is very important to do things right? And I think what I talked about before, right? So pets are not kind of sprinkles that you kind of add to your kind of data, right? And then you end up with protection, right? I think it is possible. So that is my answer, and it just needs to be done right.
Yeah, and it's kind of a principle of eat your own dog's food example.
Yeah.
No, very good question. Yeah, thank you for that. Yeah,
thank you.
And anything to add? But I think it's clear. Next one.
So thank you for this panel. It was really interesting. I don't have a technical background, so it was really interesting to hear. I'm a legal researcher, and there have been some very interesting developments in the last few months. You probably heard some buzzwords going around. The digital omnibus, of course, is coming. And there was a case called SRB case, which kind of reopened into discussion the definition of personal data and emphasize the importance of context and who actually has access. And the pets, while keeping the term pet washing in mind, pets could actually benefit from these new developments. Like I was wondering, are you in contact with national data protection authorities? Are you did you have any discussions about this recently, or are there any developments on your side in relation to these legal developments?
I would say that, in general, it really depends on the country, on the regulator, and so on, in terms of how active they are around pets. So, of course, not EU, but the context of UK GDPR, ICO, for example, published their pets guidance. But including also with Department of Science, Innovation and Technology that Dave used to be in, they have a tool that can assess the utility and usefulness of kind of cost-benefit analysis of different pets. And they're also kind of more open when it comes to kind of discussing things like differential privacy, synthetic data in the context of anonymization in their latest anonymization guidance. Of course, there's supposed to be an updated anonymization guidance from the European Data Protection Board. So we'll see what that says. But the different kind of regulators do actually look at that and think about kind of pets for kind of different use cases. I know that recently also Singapore published their pets guidance as well, which sits under the IMDA. There, so you definitely have those sort of discussions, and then for like specific use cases, there's also like guidance. So for example, I think back in 2020 there was guidance on supplementary measures on sufficient supplementary measures on kind of sharing data outside of the EU, where kind of secure multi-party computation was kind of listed as one of the methods that could be used there as a sort of supplementary measure, for example. So there's definitely kind of different discussions and also even more broadly, I think Matthias mentioned Digital Services Act, right, where there is this sort of Article 40 that talks about vetted researchers being able to access data from very large online platforms. And again, that's one of the things where kind of pets can come in. I think that what would be, now having said all of that, definitely that's one of the core things is that, and I think a lot of people in the community talk about it, it would be helpful to have more concrete guidance from regulators, or even providing more of incentives for actually implementing pets in the real world.
Yeah, maybe that's opportunity for next year to invite some representative of a regulator on a panel. But yeah, that's the situation.
Hi. Thank you very much. I would like to say that indeed the digital omnibus add extra dimension in the universe, like it makes the protection of the transfer as a function of space and time. So you do not need only cryptographers, but also physicists that eventually will guide the dynamical evolution of the pet applied. So it's yeah, okay, no, it's a big challenge indeed, and I actually do not think that it will favor pets, because the guidelines are so blurry that possibly there will be the emergence of many statistical approaches that are ad hoc, and that it will be difficult to be harmonized between different deployments, use cases, institutions. So in the end, it will maybe create a zoo that is little tested, and yeah. So I am a bit skeptical about that. But apart from her, I wanted to ask. Okay, so which is your expectation for the standardization of post-quantum pets? Which year, more or less, which decade? Decade.
So in terms of the kind of post-quantum cryptography, I guess probably not sure about how people feel about it. That's of course like an important part in terms of the kind of the encryption, and in a sense kind of like more standard encryption. So it's of course part of pets, but probably most of the people don't think about it from that perspective. You know, when you think about pets such as, you know, fully homomorphic encryption, like most of those schemes are kind of lattice based and are again believed to be secure against quantum attacks. When you think about things like differential privacy, again, like quantum computers don't give you any advantage there, because it's supposed to be kind of anonymized data. When it comes to things like confidential computing, that very much kind of relies on standard cryptographic schemes. You know, your digital signatures, your you know, like symmetric and asymmetric encryption, and so on and so forth. That's of course, that needs to adopt whatever is going to be the kind of the adopted PQC schemes. Of course, there was the NIST process on kind of selecting the new cryptographic schemes that are, you know, believed to be secure against quantum computers. Again, I don't have any kind of strong opinion on that. Like, in a sense, you know, it's part of the kind of the whole movement in terms of like what schemes are chosen, which ones are we going to adopt, what are going to be the parameters, the key lengths, and so on. And pets, like at least all the pets that we kind of spoke about, I don't think that they're necessarily impacted in any other way than just a standard symmetric or asymmetric cryptography. And from that perspective, symmetric is not that impacted because like the quantum attacks on that basically give you any kind of quadratic speed up, while asymmetric are, and if they're, for example, based on RSA or things like this, where there are efficient quantum algorithms, in particular kind of Shor's algorithm, that can factor, for example, numbers in polynomial time. So in general, like I don't think pets are necessarily impacted in any particular way when it comes to that.
Okay, I think that some of them are impacted.
Sure.
That will need actually big work to be transformed to the fast quantum version. So, okay, you don't know when, let's say, we could have standardized versions of zero knowledge proofs or...
Sure. Okay. So when it comes to like confidential computing, for example, that would just follow the normal, let's say if you're using confidential computing on GCP or AWS or whatever, you just hope that they, of course, implement the kind of the new standards for encryption, right? So that's what I mean, that it's going to be impacted, but it's going to be impacted in the same way and a standard way in terms of like secure communication. When it comes to anonymization, it doesn't really matter from that perspective, kind of from the output privacy perspective. Zero knowledge proofs, yeah, that's probably a fair point. And fully homomorphic encryption, as far as I know, like most of the schemes are believed to be quantum secure in the same way as, because they are based on kind of lattice-based systems.
Okay, yeah, thank you. Any last minute question from the audience?
I still
yeah.
had
sorry.
I got the microphone.
Please go ahead. Yeah.
I see that we're also out of time, so maybe very quickly, which feels like a bit of a basic question after this one, but we are also, I'm from the province of South Holland, and we're also inquiring more in digital autonomy and how to reach that. And well, on open source, definitely maybe on open source pets, I can imagine my colleagues saying, yeah, but open source is not safe, which I feel like, yeah, is a bit like an outdated question, but definitely on pets, I can imagine this is going to come back. So I'm asking, like, what can I tell them from a more, well, to my CISO, for example. Not sure if he has this opinion, by the way, I'm to be clear on that, but what can I tell them to convince them to use open source pets?
Yeah, Yuri or Dave?
Yeah, I mean, like, I guess when you say an open source is not safe, I wonder what it means. Is it about, for example, supply chain attacks, right? Is it about that you depend on a particular version and suddenly it's updated and you have, kind of backdoor there? But it looks like all modern privacy and security is built on open source, right? So I think, my opinion is the opposite, right? If it's open source, it means anyone can, attack it, try it. Right. For example, actually, like Rob mentioned before the meeting that they analyzed differential private libraries, try to find vulnerabilities, found bugs, published paper about this. So if it's open, it is more safe than it's not open. That's at least my perspective.
I would agree. I'd also just give a quick anecdote. In the UK at the moment, again, to talk about the NHS, there's a story last week where managerial people in the NHS have made the decision to close down all their open source repositories. Because they're scared of Claude Mythos, right? This has been widely ridiculed by the security community as being a bad idea. So yeah, I agree with everything Yuri said, and just thought that was a fascinating example. So yeah, hopefully that gives you some ammunition.
Yeah. Okay, I think we finished with questions. So yeah, I would like to thank all speakers for really, really insightful discussion, and also audience for really, really interesting questions and very relevant questions. And yeah, we hope that maybe we will try to organize something next year. I think we already got some ideas already who to bring and what to do. But meanwhile, yeah, enjoy your evening and the rest of the conference. Thank you. And feel free to contact our speakers offline. Yeah, thank you.